All right, so in this video, we're going to talk about the law of cosines. So we've talked about solving triangles that aren't right triangles. We talked about solving triangles that are right triangles using the Pythagorean theorem or SOHCAHTOA. When it's not a right triangle, you can't use those, but you can do law of sines. And we learned sometimes there could be an ambiguous case where maybe there's no triangles that are possible with given sides or angles, or maybe there's more than one. And then to solve triangles that we can't solve with the law of sines that aren't right, we're going to use the law of cosines. So the law of cosines is kind of like an addendum to the Pythagorean theorem, meaning like they're pretty similar. So if you remember, the Pythagorean theorem was a squared plus b squared equals c squared. So in an obtuse triangle, all right, that was if you use the converse of the Pythagorean theorem, if the hypotenuse squared was bigger than the leg squared, then it's an obtuse triangle. And if the hypotenuse squared was less than an acute triangle, then, if the hypotenuse squared was less than the legs squared added together, then it was an acute triangle. Which means that in an obtuse triangle, if c squared is bigger than a squared plus b squared, then c squared should equal a squared plus b squared plus something, right? Because the right side is smaller than the left side, so you gotta add something to make them equal. And in an acute triangle, you have c squared equals a squared plus b squared minus something, because now the right side is bigger of that inequality, so you gotta subtract something from the right to make them equal. Now that something is where the law of cosines plays in, all right? If that something is negative 2ab, so negative 2 times a times b times the cosine of c, then you have what's called the law of cosines. So it's c squared equals a squared plus b squared minus 2 times a times b times cosine of c, where a, b, and c are side lengths and angle c, or uppercase C, is an angle. So anytime you have a triangle, all right, they don't have to be called angles A, B, and C. But what this formula references is that for lowercase a, b, and c, you're plugging in the side across from angle A, the side across from angle B, and the side across from angle C. And so it doesn't matter which sides you make A, B, and C. Unlike the Pythagorean theorem where like c squared has to be the hypotenuse or the biggest side. Here, it doesn't matter which one's the biggest side, which one's the smallest side. What does matter is that the side C, all right, is across from angle C. So if you're plugging in for lowercase a, b, and c, then you're solving for the angle across from this side, whatever side that goes there, all right? Or let's say you're given two sides, then that would go in for a and b, all right? So if you were given these two sides, a and b, and you plug it in for a and b, which also appear there, then this angle that all right, would have to go there, and again, has to be between A and B. Then this side here is going to be the side across from angle C. So pretty much, it doesn't matter which sides A, B, and C, as long as side C is across from angle C. As long as that's true, then you can use the law of cosines. If you plug in everything and you have two variables, you're either doing something wrong with using the formula, or you should be using law of sines. If you're ever doing your law of sines and you have two missing variables, like two unknowns, then you should be using the law of cosines. All right. Now, a better way to figure out when you should use the law of sines and the law of cosines is to figure out what the case is. So if you're given three sides or two sides and the angle in between those sides, then that's when you want to use the law of cosines. All right. If you're given two angles in a side, then that's when you want to use the law of sines. So angle side angle or angle angle side, use the law of sines. And if you're given two sides and the angle not in between those two sides, that's when it's the ambiguous case, all right? Meaning it could be, I don't think I spelled that right. Maybe I did. That means there might be two triangles that are possible. There may be one triangle that's possible. There may be no triangles that are possible. But if there is a triangle that's possible, then to solve for it, you would use the law of sines, right? So we're going to use the law of cosines anytime we're given the side case or the side angle side case. So let's apply it here. Oops, I'm still learning all these parts. Oops, okay. So find the length of CT in triangle CRT. All right, so just because it says that that angle down the bottom left corner is C doesn't mean that it has to be C in the law of cosines. All right. So if I type out the law of cosines real quick, all right, that is C squared is equal to A squared plus B squared minus 2AB times the cosine of angle C. So since I have given an angle, right, I'm going to call that angle angle C. So this angle is going to be angle C because it's the only angle that I know. So it means I have to plug it in right there into the law of cosines, right? Which makes R, the side I'm looking for in the formula, that's going to be side C. All right. Now, for side A and B, it doesn't matter which ones I make A or B, as long as A is either 45 or 52 and B is the other one. All right. So since these are the two sides in between the given angle, in my formula, that's going to be A and B. Okay. So now we're just going to type all that into the calculator. All right. So at this point, I would just use the calculator. I'm going to open up my calculator. I'm going to add a document and I'm going to type in the law of cosine. So C, now I wouldn't type in this part. I'm just doing C squared equals because I'm trying to teach you this. So, but I would advise you to just type everything to the right of the equal sign, especially if you don't have a TI Inspire. All right. Oops, I changed the slide. All right, so now I'm going to do 45 squared. So C squared equals 45 squared plus 52 squared minus 2 times 45 times 52 times the cosine of 36. All right, now we've been working a lot in radians and in degrees. So your calculator, there's a good chance it's in radians and there's a good chance it's in degrees. Probably like 50-50 chance. So we want to make sure our calculator is in the right mode. Now, this angle is given in degrees, angle R. So we want to make sure that our calculator is in degrees. So I hover over that and I see it's in degrees. So that's good. If it wasn't, I would just click on that, hit document settings, and then change this to degree, and then hit OK. All right, now, because I have a TI Inspire, it's going to simplify that down for me. All right. Now, it's a side length that I'm looking for, and I would usually accept you. I'm pretty much always in this case going to accept an answer that's not exact, an answer that is a decimal. So at this point, you could take the square root of that number. All right. So type that in under the radical. I'm going to erase the C equals part because I said, you probably shouldn't write it. I just wanted to make sure you know what I was talking about. All right. And then hit Control Enter. All right. And that is going to be the length of side C. So in the law of cosines, in this particular picture, right, that's going to be the length of side R. It's going to be around 30.7. All right. And always do like a mental common sense check. All right. Meaning like, all right, this is 36 degrees, which means that these angles, at least one of them has to be bigger than 36, which means these two, or at least one of these sides should be bigger than this side, and they are. But they're also still relatively close to those side lengths. Like if this came out to be like 3, not 30, then I'd probably think I did something wrong. Or if it was too big, I probably think I did something wrong. The most common mistake that I would probably see with this is that people forget to take the square root. Like they would do this and then put their answer as a decimal and then say, okay, the length of side CT is 942.8. But then you do a common sense check and you're like, well, how the heck are those other sides so much smaller compared to that? And then you'd see, oh, okay, C squared is equal to 942.8. So you'd have to take the square root and you would get the same answer. All right. If you took this, I don't feel like doing that, but oops, sorry. Around here, we're going to get around 30.7 again. Oh my goodness. Perfect. Cool. So that's it. Now, I do want to show you one more thing, especially if you have a scientific calculator. So when I used to teach this in geometry, a lot of students didn't have TI Inspire, so they would have to evaluate this without having to, without being able to type it all into the calculator at once. If you had like an iPhone calculator, how would you do this? So if you had to evaluate this and solve for C, remember PEMDAS. So like the first thing I would do is I would do 45 squared, right? And that's 2025. And then do 52 squared, right? And I'd get that's 2,704. All right, then I would do 2 times 45 times 2 times the cosine of 36. See what that comes out to be, all right? And then now we have to do a squared plus b squared minus 2b times cosine of c. So then I would have to type that in my calculator, that plus that minus that. And then we get what c squared is, and then you take the square root. So I just felt like that it was worth going over that because A, maybe you don't all have PI inspires, and B, you should know the algebra behind that. And it's simply PEMDAS, but in geometry, people would forget all the time. No problem. All right, so now let's try example 2. So how do you use the law of cosines when you're given 3 sides? All right, well, in the law of cosines, remember, we have the formula is this, a squared plus b squared, c squared equals a squared plus b squared minus 2ab times cosine of c. So that's a, b, and c lowercase is where you plug in a side, and uppercase C is where you plug in the angle. So how do you know which sides to plug in for A, B, and C? All right, the answer is pretty simple. It depends on what angle you're looking for. So if you're, whatever angle you're looking for, you want C to be the side across from that angle. So in this example, it says find angle Q. So in the formula that I just projected on the screen, I'm going to make side Q C. So in the formula, this is going to be side C because I'm looking for this angle, right? And then this would be side A, and that would be side B, right? Now I could switch that. I could make this B and this A. All right, B and A are interchangeable, but C has to be across from the angle you're looking for or the angle you're given. All right, one of those two things has to be true. So now, how do we type that into the formula? So I'm going to pull up my calculator. I'm sorry, this just don't respond. Nope. Okay, so let me just get all this off my screen. I'm going to make a new doc. You don't have to, just for the people watching at home. We'll make it less complicated if I start fresh. So, all right, so c squared is equal to a squared plus b squared minus 2ab times cosine of c. So the formula looked like this. Remember, we said side q was c. So I do 50 squared, right, is equal to a squared, we'll make a 225, plus b squared, we'll make b 175. All right, and again, you could switch those last two, minus 2 times 225 times 175, all right, times the cosine of c. All right, now we have to solve that equation. Now, if you have a TI Inspire CAS, I mean, you could do solve that and then solve for C, and we'll see what happens. It'll probably work. I don't know. All right, so you get this weird answer. We'll put it as that, and I don't know what's happening here. So if let's say we just make this 1, and then I'm just trying to see what happens here. All right, so you get one angle. Well, that obviously doesn't make sense. So I'm not sure what's happening, but here's how you should solve it anyway, because I'm sure there's a way to do it with the solve function. Maybe I'm not in the right mode or something, but anyway, I don't want you to do it that way. I want you to know how to solve this without using a calculator. So we need to isolate the cosine of C. So to do that, we need to subtract this and that on both sides first. Then we'll have a number is equal to this, 3 numbers multiplied by the cosine of c. Right, then we could just divide both sides by this. All right, so to solve this equation, all right, ignore this part. I'm going to take 250 squared, right, subtract 225 squared on both sides, right, subtract 175 squared on both sides, right, and we get that number, right, which would equal negative 2 times 225 times 175 times the cosine of c. Right. So now we just have to divide both sides by this. So I'm going to take my answer and actually divide it by that. And this will equal the cosine of c. That didn't work. I meant to do, see, I didn't use parentheses, so I didn't divide by 225. I was sloppy with typing this in. All right, so this should equal the cosine of c, over 21. All right, usually that's going to come out to a decimal, and that could be represented as a decimal, but it ends up being a nice rational number. So now we have the cosine of c is equal to this, and now we have to solve that. So remember, to take, well, we're going to do cosine inverse here because you want to switch the domain and range to get what angle c is. Now remember that cosine inverse will give you angles in quadrant 1 and quadrant 2. So between 0 and 180 if the calculator is in degrees, all right? And it is. Now, so since that number is positive, it's going to give us the angle in quadrant 1, which would be acute, all right? So that means that angle Q is 76 degrees, all right? And if you wanted to find the rest of the angles, you would just have to do the law of cosines one more time to either angle D or angle E. And then you only ever have to do it twice, because then the third time you could just subtract the other two angles from 180 to find it. So whenever you use the law of cosines, you're going to want to use it twice, all right, if you're solving for the whole triangle. Now, you may be thinking, why do you have to use it twice? Let's say we had this angle was 76 degrees. That's what we just found out. I'm rounding. Can't we use the law of sines to, let's say if we have to find angle D, all right, we know this angle, we know this side, we know this side, all right, and we're looking for this angle. Would the law of sines work? All right, yes and no. All right, the end of it is I don't advise that you use the law of sines here, and I'll explain why in the next slide. But you can use the law of sines. You have enough information to use the law of sines. But you're going to want to use the law of cosines a second time when solving for an angle, two angles in the side, 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 or side angle, side case, because it's something that has to do with the ambiguous case. All right, so let's look at that. Yeah, no problem. If you're having Wi-Fi issues, no big deal. I am recording this, so. All right, so here's a summary of what I was just talking about. All right, so danger warning, watch out. All right, I stole this from Mr. Turkington's old notes because I really liked it and there was nothing I wanted to add to it, so I just copy and pasted it. So you can thank Mr. Turk for that. So why do you want to use, so the rule in that box is if you use the law of cosines once, use it twice. All right, here's a reason why. And again, it has to do with the ambiguous case. So let me get my annotate thing ready because I'm going to be using this. All right. So let's say we were solving for this triangle here, triangle ABC, where side A was 6. All right, so let me draw this on the picture here. All right, side B was 23, and side C was 18. All right, so method 1, all right, right here. All right, we use the law of cosines, and we find angle A. All right, and we get that angle A right here is about 9 degrees. All right, I'm rounding that. Okay, now if we did, now this right here is just the law of cosines, but it's solved for the side. No, sorry, solved for the angle. So that's why everything's like in the cosine inverse. That's pretty much what we just did, but that's all in one shot. And you can certainly do that too. All right. Then for angle B, if we did the law of cosines here, all right, we would get that this angle was 141 degrees. All right. Now, let's, all right, and then you find the third angle and you get it's that. Okay, that's using the law of cosines twice. Now, what would happen if we did the law of sines twice? Okay, so everything in pink would be the same for using the law of sines twice. All right, so those side lengths would still be the same side, and you would use the law of cosines first to find that that angle is 9 degrees. All right, but when you do sine inverse, all right, of angle B, you end up getting that angle B is 38 degrees, not 141.8 degrees. All right. Does anyone see any relationship between those two angles and have any idea why we would get a different answer? So if we think about it, all right, we're using the law of sines here. All right, we're using 9.35 degrees. So we're using this angle. All right, and we're using 6, which is this side. All right, and then we're using 23, all right, to find this angle here. Well, look at that. That's an angle, side, side. All right, so angle B, all right, when you do the law of sines, because sine inverse, all right, is only going to give you angles between 90 and negative 90. All right, in other words, it won't give you an obtuse angle when you do sine inverse, because that's how sine inverse is defined, to give you angles between angle 1 and angle quadrant 1 and quadrant 4. So it's not going to give you this angle, all right? It's going to give you the supplement of that angle, 38 degrees, because what it really thinks you're doing here, all right, is it really thinks you're solving this triangle here, where this side is 6, all right, and now that's angle B, all right, because this angle is still 9 degrees, this side is still 23, angle side side, it's the ambiguous case. So it's not considering angle C, and it's assuming that angle C is the obtuse angle. All right. So because law of cosines will give you an obtuse or an acute angle, you're going to want to use it twice because um, if one of those angles happens to be obtuse, like in this case, if you were to do a law of sines, it's going to give you the angle in quadrant 1, not the angle in quadrant 2. All right. And notice how, again, how both of these angles have the same reference angle. All right. They both have 38 degrees reference angles, but cosine inverse is negative in quadrant 2. All right. And this number right here is negative. So that's why I give you the proper angle in quadrant 2. Here, when you do this, all right, this stuff still comes out to be positive because again, thinks you're doing this triangle here. So it has to do with the ambiguous case. All right. Hopefully that wasn't too complicated. One last thing, if I can figure out how to get rid of this on my screen. Oh, perfect. All right. So if you, instead of like making, so I described earlier that side C is across from angle C. If so one way to do this is to always relabel your triangle so that side C and angle C, those are across from each other, and you're either given angle C or you're looking for angle C. All right. Or if you can label your triangle anyway, and then you can use any of these versions of the formula. So like if you label your triangle in a way where you're looking for angle A, then you can use this second formula here. If you're looking for angle B, all right, then you can use this third formula on the bottom right. So it's just like 3 different versions of the formula if you wanted to name your sides however you wanted without being tied down to the fact that angle C is what you're looking for or what you're given. All right. I like to do it the first way, but either one kind of works. And these are just the law on the right side here. This is just a law of cosines where it's solved for the angle. All right. So I just want to do one more quick example where we're like looking for an angle here. And then I will end this here. So let me draw the picture out. So we'll do 12, 60, and 49. And again, I just want to show you how to use the calculator on this. All right, so 12, 60, and 49. I don't know if those are the numbers, but let's just do it. All right, so this will be, that's an angle. So I knew I drew this kind of equilateral. It's not actually equilateral, but it's just a picture, so who cares? All right, so all I wanted to show you is this. Let's say we're looking for this angle, angle C, all right? I have to escape that, okay. So I know that 49 degrees, or 49, not degrees, 49 units is equal to 60 squared plus 12 squared minus 2 times 60 times 12 times the cosine of C. Okay. Now, if I were solving this, what I would do is type this all into my calculator in one shot. So first, I would isolate the cosine of C. So I would subtract 60 squared on both sides, right? And then subtract 12 squared on both sides. Again, I wish I could write this on a whiteboard for you, but it's just, but we can't. So then I'm going to take this whole left side and divide it by these three numbers, because cosine of C is getting multiplied by these three numbers, -2, 60, and 12. So I'll just do the inverse of that and divide both sides by that. And now I have that is equal to the cosine of C. Again, I want to put this in parentheses so I don't get caught like last time. All right, so we're taking that whole numerator and dividing it by that whole denominator. All right, now that's what the cosine of C equals. So to get what angle C is, all right, I'm going to take the cosine inverse of that. Oops, I didn't mean to hit escape, or I didn't mean to hit control. Oh man, so I'm gonna erase all this and do the cosine inverse of that. And then just hit control equals. And that is a quick way to just get your angle in one shot. All right. And that's it. Now this does look a little weird that it's so small, but 49, hopefully I didn't do anything wrong. I don't think I did anything wrong. No, it's good. I don't know. I'll think about it and I'll let you know. But that's it. So hopefully you now know how to use the law of cosines. So I'm doing my common sense check right now and I feel like that's low. So I'll look into that. But I'll end the video here. If you have any questions, let me know.